Hello grade 12s. This is a video entitled Equation of a Tangent to a Circle. So we've been discussing circles in analytical geometry and how to find the equations of circles. The second most important work that we're going to be doing is how to find the equation of a tangent to a circle. Now if you want to find the equation of a tangent to a circle, please people, do not confuse this work with the work that we did in differential calculus. We are not going to use differential calculus techniques here at all. So we're not going to use any of those gradient techniques that you learned in that section. This section is going to be purely based on the Euclidean geometry theorems. So based on the Euclidean geometry theorems, very important to remember is the following. If I draw a tangent to a circle and then I draw the radius, so from the center of the circle to the tangent, then hopefully you guys will remember that the radius is always perpendicular to that tangent. So very important to remember here. Radius, or for that matter the diameter, is perpendicular to the tangent. Same thing over here. If I go and I draw, for instance, a diameter, then if I draw diameter all the way through, that's also a 90-degree angle. Now this is very important to remember, obviously, because when two lines are perpendicular, we know that the product of the gradients are equal to -1. So we know that the gradient of the radius times the gradient of the tangent is equal to -1. Or I can adjust that slightly and I can say the gradient of the tangent is equal to -1 over the gradient of the radius. So this is what we are going to use to find the equation of a tangent. So let's look at an example. How to determine the equation of a tangent to a circle. So this is example 2 on page 259 of the textbook. It says, the equation of a tangent to the circle x squared minus 6x plus y squared plus 2y is equal to 10 at the point of contact, which is the point T, and that has been given coordinates 5, 3. Now again, I haven't done the Lozanne method in the previous section all that much, but we're going to do the Lozanne method much more over here. So you'll see I've already written down all of the steps quite carefully on how to determine the equation of a tangent, step by step by step. It's very easy to follow. The first step, determine the coordinates of the center if required, because as you can see over here, we need to go and we need to find the equation of the radius before we can find the equation of the tangent. So if we don't know what the center of the circle is, we do need to get the point that is that center of the circle. So determine the coordinates of the center if required. Now this normally involves completion of the square. Like I showed you in the previous video. So as you can clearly see, we don't currently have the center of the circle because it is not in standard form. It is currently in that format where we can't say what the A value and the B value is for the center of the circle. So here's step 1. Yes, we're going to have to go and determine the center of the circle by means of completion of the square. So I'm going to write that out. Step 1. And I'm going to say it's x squared minus 6x, leave space to complete that square, and then I'm going to say plus y squared plus 2y, leave space to complete that square is equal to 10. Now hopefully you guys will remember from the previous video, it's pretty easy and straightforward. It's a little rhyme, half it, square it. So I take that b value, or I should rather say the coefficient of x, and I should say minus 6, half it, so divided by 2 gives me minus 3, and then square it. Careful, when you square a negative, it always becomes positive. So -3 squared is plus 9. So I add 9 there. Same thing there. 2, half it, so divided by 2 is 1. Square it, still gives you 1, so that's plus 1. So now I've added 9 and 1, 10 on the left-hand side, which means I need to add 10 on the right-hand side to balance this equation. That is then a perfect square, so I can put the bracket down and I can say it's x. And please remember what goes inside the bracket is what you got when you halved that coefficient of x. So minus 6 halved is minus 3. Plus then over here, we've completed the square for y, so we can again go and say it's y, and again what goes in there is what I had after I halved it. So 2 divided by 2 is 1. And that's going to be equal to 20. Now, before, I didn't know what the centre of the circle is. Now I know the centre of the circle is the point 3, negative 1. Remember to change those signs. So centre is the point 3, negative 1. So that's step 1. Determine the centre of the circle if required. Now, step 2. Step 2 then says determine the gradient of the radius. So to determine the gradient of the radius, you have to remember the gradient of the radius goes from the centre to the point of contact, which is a point on the circumference. That's obviously going to be the radius from the center to that point of contact. So for step 2, we use that gradient formula and we say the gradient of the radius from the center to the point of contact, minus 1 minus 3 over 3 minus 5. And that is going to be minus 4 over minus 2, which is equal to positive 2. Then, step 3. Step 3 is then going to be determine the gradient of the tangent by remembering the product between the gradient of the tangent and the gradient of the radius is equal to negative 1. So if I multiply these two gradients, I get to negative 1. So the gradient of the tangent times 2 is negative 1, which means the gradient of the tangent is equal to negative 1/2. Then, next, step 4. Step 4, you can then determine the equation of that tangent by remembering we've got the gradient of the tangent, and careful, very important there, we've got the point on that tangent. But that point on the tangent, you have to remember, it's the point of contact on the circumference. Lots of people make the mistake when they sub this point in to sub the center in. Please, the tangent does not go through the center of the circle. The tangent goes through a point on the circumference. So watch which point you substitute in. Make sure it's that point of contact, the point on the circumference. In this case, it's that point T. So the point 5,3 is that point of contact. Right, so step 4 is then going to be y minus 3 is equal to the gradient of the tangent that I've worked out there, which is negative 1/2, times then x minus 5. And again, remember, don't use the center of the circle. The tangent does not go through the center. It's got to be the point of contact. It's got to be the point on the circumference. So I can clean this up and I can say y is then equal to minus 1/2 times x. And then I've got minus 1/2 times negative 5. And then I have to add 3, which is going to be plus 11 over 2. And that right there is the equation of the tangent to the circle. So if I ask you for the equation of the tangent to the circle, very easy, very straightforward. Please, please, please don't complicate it. And there, just again, your steps. Step 1, determine the coordinates of the center if required. If it's not clearly given, generally it involves completion of the square. Step 2, determine the gradients of the radius. Careful, that's got to go from the center of the circle that you calculate in step 1 to the point of contact on the circumference. Then you can determine the gradient of the tangent because of the fact that the tangent is perpendicular to the radius. And then you can just sub it into that equation formula. So pretty easy and straightforward. Now, haven't referred to this method in a while. What if they go and they're complicated? In other words, the Joshua method. Yes, great, understand, but how can they make this more difficult? Well, the only real way to make this more difficult specifically is to go and instead of giving you the point of contact, you give the equation of the tangent. And these questions have become more and more common in the IB final paper. So, if the equation of the tangent is given, but they don't give the point of contact, so you can add to that, point of contact is not given. And I've managed to find an example here in one of the past exam papers. So this is from the IB Supplementary Paper 2 from March 2018. And it's question 7. It gives you the following diagram, and then it says, ON, so right there from O to N, is a tangent to the circle at point M. So point M right there is the point of contact of that tangent to the circle. The equation of ON is y is equal to 2x. So they've told you the equation of that tangent. They said this y is equal to 2x. That's the equation of the tangent. So like I explained to you, this happens when the equation is given, but the point of contact is not given. So the coordinates of that point M is not given. The equation of the circle is x squared plus y squared minus 20x plus p is equal to 0. So again, you'll notice this is not in completed square form. So whenever the circle is not in completed square form, you are probably going to have to complete it. K is the center of the circle. So they've told you right there, point K is the center of the circle. Determine the coordinates of M. Now, obviously here, they're not going to ask you to determine the equation of tangent because that's been given. Okay. So they've given you the fact that the equation of that tangent is 2x, so that can't be the point of this question. The point of this question is to get the point of contact. So in the previous example, let's just go and slow this down. I've said that if you have the equation of the circle and you've got the point of contact, then these are the steps you follow to get the equation of the tangent. If, however, you have the equation of the circle and the equation of the tangent, then these are going to be the steps you follow to get the point of contact. So that's the difference between the first example and this particular example. So let's take a look at it. Now, in order to get that point of contact, we are going to have to get the equation of the radius. Now let me explain that to you. The reason we need to get the equation of the radius is the following. The radius cuts the tangent at the point of contact. So if I can find the equation of the radius of the circle, and I can go and I can set that equation of the radius equal to the equation of the tangent, in other words, solve them simultaneously, or find the points of intersection, then I've got that point of contact. So that's the goal here. The goal here is very simple. Find the equation of the radius, then go and solve the equation of the radius and the equation of the tangent simultaneously, or set them equal to each other to find that point of intersection. Right, so let's get started. So in this case, step 1, to find that equation of the radius, we're going to need the center of that particular circle. So we're going to go to this equation and we're going to say, step 1, let's find the center of the circle. Same as the previous example. So we're going to say x squared minus 20x, leave a gap there, plus y squared is equal to minus p. Now it really doesn't matter that there's a p there. That p value is going to be a constant value. It's a constant value because it doesn't stand next to an x. That's why I can just put it over to the other side and not have to worry too much about it right now. Okay, so please note that there I've got a 20x, but there I don't have anything. Now this is what happens when our y is already in completed square. So we'll talk about that just now. This one needs to be completed, so I can then go and say minus 20 must first be halved. So if I half it, I get minus 10. And then if I square it, I get 100. So I add 100 there. This one, like I said, because there's no y, it's already in completed square, I can leave it the way it is. So this bracket, oh, sorry, almost forgot. I added 100 to this side, so I need to add 100 to this side. Please, please, people, don't forget that. If I add values to the left-hand side of an equation, I always have to add values to the right-hand side. So I can then go and say this is minus p plus 100. Now this one's obviously then going to be x minus 10. That's the value I had when I halved it before I squared it to add what needed to be added. Now this means the center of the circle there is the point 10, 0. Now we haven't had many examples like this, but please, 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 people, remember, if there is no y value, like in this case with the x value, so there's no like a coefficient with x next to it, you need to understand that that just means you've got y plus 0 squared. And because you've got y plus 0 or y minus 0, it means the y coordinate of the center is 0, which actually makes a lot of sense, simply because of the fact that if you look at the diagram, you'll realize, K, the center of the circle, lies on the x-axis, which means the y-coordinate had to be 0. So that is one of the things you could have realized there. So that's step 1, finding the center of the circle. Now that we found the center of the circle, we need to find the equation of the radius. So this is going to be step 2. Now you'll note, last time when we found the equation of the radius, we used 2 points to do it because we had the center and we had the point of contact. Now we don't have the point of contact. So what we need to do here to find the equation of the radius is we need to go and we first need to find the equation of the radius by using the tangent. So we're still going to use that principle that the tangent is perpendicular to the radius. So we're going to say the gradient of the radius times the gradient of the tangent, which was given over here. They said the equation of ON, so the equation of the tangent, is 2x, so that means the gradient of the tangent, and I can write it down over here, is equal to 2. So the gradient of the radius times 2 is equal to -1, which means the gradient of the radius is then equal to -1 over 2. And then I can just go and I can use this point. Because like I said, we're not currently trying to find the equation of the tangent. We're trying to find the equation of the radius. So that'll be the next step. And I'm going to use the center, because obviously the center does lie on the radius. Center lies on the radius, and then that one. So this is going to be step 3. And that's going to be y minus 0 is equal to -1/2 times x minus 10. And like I said, this is the equation of the radius. So that's going to be y is equal to -1/2 x, and then obviously -1/2 times -10 is going to be equal to +5. Now I've got the equation of the radius, and I had the equation of the tangent because that was given to me at the very beginning. So I can then go and I can say, step 4, solve these two simultaneously or set them equal. The tangent's equation was 2x, and the equation of the radius is -1/2 x plus 5. So that's going to be 2 plus 1/2 is then equal to 5 over 2x, which is 5, and then I can divide both sides by that 5 over 2, and I can get x is equal to 2. So that right there is the x coordinate of point M, my point of contact. And then obviously to get the y coordinate, I can just sub it in into either one of these two equations. This one will obviously be the easier one. So therefore point M, which is the point of contact, is the point 2, 4. So that's what happens if you have the equation of the tangent given to you, and you've got the equation of the circle given to you, but you need to find the point of contact between the tangent and the circle. So just looking at these steps one by one again. Step 1 there, we said find the center. And that we did simply by doing completion of the square again. Then we went and we said, now find the gradient of the radius. And that we also did by just using that idea that the product between the gradient of the radius and the gradient of the tangent, which was given to you, is equal to -1. Then step 3 was find the equation of the radius. There you go. And then the last one was then set the equation of the radius equal to the equation of the tangent and solve simultaneously. And that gives you a point of contact. Right. Thank you for listening.